1.8 for partial fractions. Sometimes it is useful to, what we've always done in the past is had fractions or rational functions that look like this. And we're happy with that because this is what we've been trying to get it in the form of. But now sometimes we're going to be given this form and we want to break it down back into this original stuff, which is usually what we've been given lately. And we've been asked to get it from this right side to this left-hand side. And now we're going to be going back and doing the opposite thing, that we'll be given something like this and we'll be breaking it back down. When we break it back down, that's called partial fraction decomposition. So in generic terms, we call this top part of this left-hand side fraction just p of x, and the bottom is q of x. So what we're going to have to do first is check the degrees. So then if degree of p of x, is greater or equal to q of x, then we will actually do the division. Oh, I can't write. The division. That means you could do longhand division. You could do synthetic division if you were able to, but probably most of the time that means doing like longhand division. So that's our first step that we're going to take every time, and we're just checking the degree on that first step. And after we've done the division, we will do the following steps on what we have left. Whether that is the remainder or the new resulting p of q, which won't be the same, p over q, do the following steps. I'm just going to write to fractions, but it's really to rational, anything rational you have. Okay, then we will have p of x's degree should now be less than q. And as soon as the degree is less, then we are going to be factoring q of x. Then factor the denominator. And we want it mostly into linear factors when we factor this. But if you have something quadratic that isn't factorable, that's okay as well. And then the third step gets really weird when you're reading it through the book, because it's just a lot of P's and Q's and A's and B's and C's. What we're going to do is we're going to take, and we're just going to give the top, we're going to make a couple different fractions, however many we need to, and we're going to give them basically just a letter on top to represent that we are going to find that thing that happens. And then we could have a to the n. I have no idea what they actually call it. They do call it a to the n. And we're going to do the factors of q. So factor of q, I'm just going to write it a little bit differently than what they have. This is also going to be a factor. And this will also be a factor. Okay, and then we will be solving for some different things. And then even if you read the next steps in the book, it basically says, now follow the next examples, which kind of make me laugh because it is just so confusing sometimes to try to say. So we've already been given what 4x minus 13 over 2x squared plus x minus 6 decomposes into. So what we're going to do is just go through and work through this one. And then this is kind of the steps you'll take each time. And they might vary a little bit, so we'll do a couple of them. So first thing we're going to have to do is check the degree. Is the degree of the top less than the degree of the bottom? Since it is, we can start and we're going to factor 2x squared plus x minus 6. That's our first step now. So I'm going to take 2 times negative 6, which is going to be negative 12. And I want to find something that's going to add to positive 1. To factor this guy out. And that will give me the factors that'll work will be positive 4 and negative 3. So then I'm going to rewrite 2x squared plus 4x minus 3x minus 6. Then I'm going to factor these guys down the middle. I can pull out a 2x, and I would be left with an x plus 2. Over here I can pull out a negative 3, and I would be left with an x plus 2. So then my final factors is 2x minus 3 and x plus 2. Okay, then I'm going to create from this guy, I'm going to move this stuff over. Okay, so we just factored this, and I would be left with 4x minus 13 over x plus 2, 2x minus 3. So then what I'm actually going to do with that is I'm going to say this is equal to something, I don't know what that something is yet, over my first factor. And I'm going to add to that a different something over my other factor. And if I were asked to get a common denominator right here, how I would be going about doing this from right here is I would be multiplying this guy, so I'm going to write out this different step in a different color. I would be multiplying A by 2x minus 3 over 2x minus 3. And I'd be multiplying B by x plus 2, x plus 2. So then at this point, because I'm kind of ignoring this first piece that I'm doing and only working with these guys over here. I have the same denominator on the bottom. Remember when we were working with rational functions that I could do just take the top. So I have 4x minus 13 equals A times 2x minus 3 plus B times x plus 2. Okay, so now I'm going to try to solve this, but it's really weird because I have x's and a's and b's, and what we actually want to happen is we're going to pick which one of these factors. So it's easier to do, I think, ones with whole numbers. What would make this factor equal to 0? So x plus 2 equals 0, and I get x equals negative 2. So I'm going to plug in negative 2 for all of my x's. So plug in factor that makes, plug in x that makes one factor equal to 0. Okay, so what's going to happen then when I plug in negative 2, I will have 4 times negative 2 minus 13 equals A times 2 times negative 2 minus 3 plus B times negative 2 plus 0. Negative 2 plus 2, which will then be 0. So this whole thing will add to 0 or multiply to 0. So I'm really not adding anything on at the end. And that's why we do that. And now if I kind of check out everything that I have left over here, I only have one letter that I have to solve for. So I don't have x's or b's, I just have an a that I can solve for. So then I'll have negative 8 minus 13 equals a times negative 4 minus 3, so negative 7. And then I'll divide both sides by negative 7. So 8 minus 13 is going to give me negative 21. So I have negative 21 divided by negative 7, which is going to give me positive 3 for my A. Okay, now when I picked x equals negative 2, I have to go through the same steps for my other factor. My other factor, I'll pick a different color, is 2x minus 3 equals 0. That's going to give me x equals positive 3 halves when I solve. So I'd add 3 and divide by 2. And then I'm going to plug this in everywhere for an x. So basically going through these same steps over here. So I will have 4 times 3 halves minus 13 equals a times 2 times 3 halves minus 3 plus b times 3 halves plus 2. Okay, so 4 and 2, that will be cross out to 2 and 1. So I'll have 6 minus 13 equals a. This will be 3 minus 3, so this whole thing is the one that's going to go to 0. So 0 plus b. Then I have 3 halves plus 2. That will give me, so basically 1.5 plus 2 will give me 3.5. So I would have 3.5, or we'll write it as a fraction. 3.5 would be 7 halves b. And when I divide by a fraction, I really actually am multiplying by its reciprocal. And let's do 6 minus 13 as well, and we'll get negative 7. I just want to erase it because I'm being lazy. So I'm going to multiply both sides by 2 over 7, by 2 over 7. When I multiply this left-hand guy, I get negative 2 over 1, so that's just negative 2 equals b. Then I go rewrite. I know what my a and my b is. That's the only thing that I actually had to solve for up here. And I'm going to rewrite it as this guy up here. So I will have 3 over x plus 2 plus negative 2 over 2x minus 3. And if I were to add these together, get common denominators, I would get 4x minus 13 again. Okay, so let's do an example that's going to have 3 factors on the bottom. So the original stuff that you'd be given is 7x squared minus 29x plus 24 over, sometimes it'll already be factored for you. Sometimes you'll actually have to go through and actually factor things. This one is already factored for you. And you have x minus 2 squared. So if you notice, it really only seems like I have 2 factors. But you do have to pay attention to these guys that are squared, because that's kind of what's actually different about things. So since it's already factored, you're going to try to find the degree of the bottom, which does not mean you have to actually multiply things out. It means that when I square this, I'm going to have 2. And when I multiply it by that, I will have a degree of 3 on the bottom. That means I need to have 3 fractions. So that means a plus b plus c. So what we're going to do in order to set this up is a goes over our first thing that we have there, the 2x minus 1. B goes over x minus 2. And c is actually going to go over x minus 2 squared. Because if I think about it, if I were to be multiplying these out, the only reason that I would have an x minus 2 in my denominator, the only reason it would be squared is if I had 2 of them somewhere. So we'll do this. So basically, we have to decide which each piece needs. So a, this first thing, this 2x minus 1, what is it missing in its denominator? It's missing an x minus 2 squared. X minus 2 squared. This guy, the b, x minus 2, he's missing another x minus 2. And he's also missing a 2x minus 1. 2x minus 1. And the c term actually already has 2 of the x minus 2, so he already has 2 of the factors, so now this guy only needs 2x minus 1. Okay, so what that's going to amount to is, now that I have common denominators all the way across, I can kind of ignore them and just focus on the top. So I have 7x squared minus 29x plus 24. And then I'm going to write out all my other terms a little bit nicer. And I'll have a times x minus 2 squared plus b times x minus 2, 2x minus 1, plus c times 2x minus 1. And then what you're going to have happen is we're going to pick factors that make pick x's that make one of the factors equal to 0. So when is that going to happen? We can do the 2's first or the 2x minus 1's first. It's not going to matter. I like the whole numbers first, so I'll do x minus 2 equal to 0. My eraser's not working. Which should mean x has to equal positive 2. So I'm going to plug in positive 2 in for everything. So I'll have, that's not a 2, that's a 7. 2 squared minus 29 times 2 plus 24 equals a, I'm going to go ahead and write it in there, but 2 minus 2 squared is all going to go to 0, plus b times 2 minus 2 times 2 minus 1. That whole thing is going to go to 0 because of this guy right there, plus c times 2x times 2 minus 1. Okay, then I'm going to go through and solve for c now, because that's the only thing I have left. So I'm going to have 7 times 4, so I have 28 minus 58 plus 24. So 0, 0, and then I have c times 4 minus 1 times 3. So I'm going to write that 3 out front. 28 minus 58 plus 24 is negative 6 equals 3c. I'm going to divide both sides by 3, and I get negative 2 equal to c. So that's one of our nice little answers that's going to go up here. And then I'm going to pick a letter for my other factor. So my other factor was 2x minus 1. So I'm going to do this off to the same side so I kind of have some of the same room. I would usually, if I was on paper, I would go straight below it. So I have 2x minus 1 equals 0. That's going to give me x equals positive 1 over 2 when I add 1 to the other side and then divide by 2. So I'm going to plug that in. So I will have 7 times 1/2 squared minus 29 times 1/2 plus 24 equals a times 1/2 minus 2 squared plus b times 1/2 minus 2 times 2 times 1/2 minus 1. And thankfully this guy is going to go to 0, so this whole term in the middle goes to 0 again, plus c times 2 to 1/2 minus 1, and so my c term also goes to 0. So I will just be left with the a that I have to solve for. So 7 times 1/2 squared will be 7 over 4 minus 29 over 2 plus 24. We'll get common denominators in a little bit. 1/2 minus 2 gives me negative 0.15. When I square that, I will get 9/4. So it was 3/2 first, so I will get 9/4 times a. So then I'm going to add these guys together. And honestly, I'm just doing them in the calculator. So I have 7/4 minus 29 over 2 plus 24. When I add those together, I get 45 over 4 equals 9 over 4a. I multiply by the reciprocal, so I'm multiplying both sides by 4 over 9, 4 over 9. 45, I'm going to cross simplify here. 9 goes into 9 once, 9 goes into 45 5 times, and a is going to equal 5. So now I know what a and c are, but b keeps multiplying out to 0 every time. So since these guys keep multiplying to 0, we're going to start at this step right here. I'm going to copy it over to the next page. So I have a equals 5 and c equals -2. So I need a pin. How about a pin? A equals 5 and c equals -2. So I'm actually going to plug these in for my a and my c. So I'm just going to do that right here. So I have 5 and -2. And I'm going to just write -2 instead. Same thing. Now what I'm going to do is I'm going to pick any number I want to, except I cannot use x equals 2, and I cannot use x equals positive 1/2. I can pick any other x because I have my a and my c already, and I like really easy numbers. So 0 would seem to work out really nicely. If you can pick 0, if not, you could pick 1 and go through more work. I will just show it to you with 1 because that will be more likely what's going to happen for the rest of your answers. So I have 7 times 1 squared minus 29 times 1 plus 24 equals 5 times 1 minus 2 squared plus b times 1 minus 2 times 2 times 1 minus 1 minus 2 times 2 times 1 minus 1. Okay, so that's more likely what you're going to be writing out. 7 times 1 squared is 7 minus 29 plus 24. And then I'm going to do these steps out. I have 1 minus 2 is -1 squared is 1, so that's a 5, plus b times, I'll write my coefficient out front whenever I find it. So 1 minus 2 is -1. 2 times 1 is 2 minus 1. 2 minus 1 is 1, so this will just be a -1 in front of the b. And then I have -2 times, we'll do the stuff in parentheses first. So I have 2 minus 1 is 1 minus 2. So I'm going to combine like terms now. So I have 7 minus 29 plus 24 on the left side, and that's equal to 2. And then I have 5 and -2 is going to give me 3 minus b. So I'm going to subtract 3 over to the other side, and I get -1 equals -b. Divide or multiply by -1, and I get b equals 1. So then I have to go back and look at my original partial fraction equation with the a, b, and c, and I'm going to replace that, all my a, b's, and c's in there. And so my final answer will look like 5 over, and I have to pay attention to which one they came in. So 5 was my a, and that will be over 2x minus 1. My b was just my plain old x minus 2. And my c is -2, and that was over the x minus 2 squared. So you have to make sure that you're putting the right number that we found over the right piece on the bottom. So this is what your partial fraction decomposition would be. Then the next example I have for you is I have 6x cubed plus 5x squared minus 7 all over 3x squared minus 2x minus 1. So my first step is to check out my degrees, and this one is going to be different than the other ones we did because I actually have the top is bigger than the bottom degree. So what I'm going to do is set up my longhand division, because if I wanted to use synthetic division, I would actually have to factor these guys down. So for the most part, I think you will get a better answer if you actually do longhand division. So I need to leave myself more room. So I have 3x squared minus 2x minus 1. And then 6x cubed plus 5x squared. I'm missing an x value, so I have plus 0x minus 7. Okay, so what do I have to multiply 3x squared by to get to 6x cubed? Okay, 6 divided by 3 is 2. X cubed divided by x squared is x. So now I'm going to take 2x times all of these things. So 2x times 3x squared will give me 6x cubed. Then I have 2x times negative 2x is going to give me negative 4x. 2x times negative 1 will give me negative, whoops, this is a 4x squared, and this is just a plain old 2x then. Okay, and then I have to remember to go through, and now I have to actually subtract everything. So what that's going to do is change all my signs. And then when I get those, when I add those together, these guys will add to 0. 5 plus 4 will give me 9x squared. 0x plus 2x will give me a positive 2x. Okay, so 3x squared. How many times does that take me to get into 9x squared? So 9 divided by 3 will give me a positive 3. X divided by x squared, I don't have anything left, so I have 2x plus 3. So 3 times 3x squared gives me 9x squared. 3 times negative 2x gives me negative 6x. 3 times negative 1 is negative 3. So now I add my terms together. Or first I have to change all my signs because I'm subtracting. So that's going to make it a minus 9, a plus 6x, and a plus 3. So those guys will add to 0. The 2x and the positive 6x will add to 8x. And the 7 and the negative 7 and the positive 3 will add to 4. Negative 4, sorry about that. Okay, so this guy down here is my remainder. These guys went in evenly. So when I go back to rewrite this, I have 2x plus 3 plus 8x minus 4 over my old denominator. 3x squared minus 2x minus 1. And then the only thing I have to worry is actually decomposing this last part of it. And then so the first thing I do is check my degree. Is my degree of the top less than the degree of the bottom? Good, now we can decompose it. So we're really just going to worry about this, but whenever we get a final answer, we're going to have to make sure that we put the 2x plus 3 back with it. So my decomposition will be, so 8x minus 4 over 3x squared minus 2x minus 1. First thing I'm going to do is factor down the bottom. So I'm going to try to do this over here. So I'm going to have 3 times negative 1 is 3. And that has to add to my middle term of negative 2. So what multiplies to negative 3 and adds to negative 2 will be negative 3 and 1. That works out. So I rewrite it as 3x squared minus 3x plus 1x minus 1. Okay, and then I factor these guys down, and I have a 3x, and I'm left with x minus 1. And then I can't factor out anything here, so I write plus 1. And then I'm left with x minus 1. Okay, and then I have x minus 1 here, and a 3x plus 1. Okay, so 8x minus 4 needs to be equal to something over x minus 1 plus something over 3x plus 1. You can pretty well, hopefully by this point, kind of skip to this step. So I have 8x minus 4 equals a, whoops, where's my pen, times 3x plus 1 plus b times x minus 1. Then the steps you're going to take is you're going to plug in x equals positive 1 at some point, figure out what a equals. And then you're going to plug in x equals negative 1 over 3. Then you're going to go through the decomposition that we've been doing. There is one other way that we can kind of use to decompose things. So we're going to go back to the old one that we already did. So we had 7x squared minus 29x plus 24. We've already figured out what our factors are. So this is one that we've already done. So if you didn't already have your factors, you would have to go through and do those, but they gave our factors here. So I had a over 2x minus 1 plus b over x minus 2 plus c over x minus 2 squared. So what you're going to do is another way to do this. So we had to say that 7x squared minus 29x plus 24 equaled a. So you still have to go through the same basic steps to start with. So I have x minus 2 squared plus b times x minus 2, 2x minus 1 plus c over 2x minus 1. Okay, so you have to go through these steps. And then what you're going to have to do is FOIL these guys out. And then you don't have to actually multiply anything out for the c. And then you actually have to distribute through the a, b's, and c. So the 7x squared minus 29x plus 24 stay the same. Then I'm going to FOIL out the x minus 2. When I do that, I'm going to get x squared minus 4x plus 4. And then I'm going to FOIL out the b's, or the stuff in front of the b's. So I will have a 2x squared minus x minus 4x, so it's going to be minus 5x. And then I'll have negative 2 plus, or times a negative 1 will give me plus 2. Plus, I'm going to go ahead and distribute out this c. So I will have c times 2x minus c. Okay, and then I'm going to distribute out the a and the b. So the 7x squared, that side staying the same. So I have ax squared minus a 4x plus 4a plus b times 2x squared minus 5x. A, b, I'm forgetting my b. B, 5x. I'm going to do a plus here and a negative 5x here. Plus 2b. And then I rewrite the c times 2x minus c. And then I'm going to work with just the side that has the a, b's, and c's. And I'm going to get all my x squareds together. So I kind of like to make sure I have them all together here. And that looks like those are my only x squareds. So I will have ax squared plus b 2x squared. Then I'm going to get all my regular old x's together. So these guys have regular old x's. Okay, so that'll be minus, I'm going to write that one like I did one of the b ones. And I'm going to write a and negative 4x. And then I'm going to write plus b negative 5x. And then I have the plus c and 2x. And then I'm going to get all my things that don't have x's together. And I'm going to say plus 4a plus 2b minus c. And then I just want to check to make sure I have them all together. And then what I'm going to do is I'm going to factor out an x squared out of these guys. So I have x squared. If I divided this piece by x squared, I'd have a. If I divided this piece by x squared, I'd have 2b. And then I'm going to just change my color so I'm not confused. Then I'm going to pull an x out of this next piece. And the reason why I'm going to do this is I'm making basically a systems of equations because we know how to solve systems of equations as well. So if I pulled an x out of this first piece, I would have negative 4a. Okay, it doesn't matter if I write a times negative 4 or negative 4a. Then I'm going to pull an x out of this piece, and I'd be left with a negative 5b. If I pulled an x out of this piece, I'd be left with a 2c. Okay, changing my colors. I have nothing to pull out of these guys, so I would have just the same thing, 4a plus 2b minus c. Then I'm going to go ahead and rewrite my older stuff that I had on this left side before that I was just getting lazy with and not writing it every time. Okay, now basically my systems of equations is going to look something along the lines of I have something x squared here and here. I have something x here and here. So basically what it amounts to is that I will have to have 7 has to equal a plus 2b. Okay, because 7 is times x squared. And then I have to have negative 4a minus 5b plus 2c is equal to negative 29. Okay, and then I'm just kind of dropping the x's. So I have negative 4a minus 5b plus 2c. Then my other color, I have just 24. I don't have any x's that I have to worry about dropping. And that's equal to 4a plus 2b minus c. Okay, I can set this up as a matrix. I can solve it like a systems of equations. If I wanted to set it up as a matrix, make sure that you take your numbers over here and put them on the right-hand side of the matrix. So if I was to make a matrix, I would have 1, 2, 0, 7. I'm going to make an augmented matrix. Then I would have negative 4, negative 5, 2, negative 29. Then I would have 4, 2, negative 1, 24. And even if you did the row reduced echelon form, using your elimination, however you wanted to solve this at this point. So you guys have a couple different options on how you want to decompose your fractions, but this is another option for you guys. And if you do this, you will get the same answers, and then we just have to go back and make sure you write them back like this guy. Okay, you'll get your same A, B, and C, but I want you guys to do homework on page 557. And I want you to do numbers 1 through 27 odds.